My name is Matt Gangerty. I'm from HP. I'm a product manager in their HP software team, so thanks a lot for attending. Quick run through the agenda. I'm going to talk about HP's Converged Cloud strategy and point of view that we announced earlier this week, and go into a couple more details about a couple of the solution components and products that we have within that, specifically one called Cloud Service Automation, which is one of the underpinning software technologies that supports this entire Converged Cloud strategy that we announced. Along with that, we've got a great partnership, and we've augmented those Cloud Service Automation capabilities with our partnership with Adaptive. So Nathan Wells is going to go through the actual integration, how we've expanded the value proposition and augmented CSA value with some additional Moab capabilities. And then finally, we have James Matthews, who's from our field organization, and he's going to go through a couple of the use cases that we're delivering to the field and bring some of the actual field and customer real-world scenarios so you can see how all this ties together. Okay, so strategy, some product solutions that support that strategy, a partnership that supports that strategy, and some use cases that we're actually delivering. So that's the overall structure of the presentation. So, so a couple of things just about the environment we're working in. You know, a lot of the customer challenges that we're dealing with today, a lot of these haven't changed, right? Companies are always looking to beat the competition, deliver increased customer value, and speed the innovation and product development cycle. So that's a key customer challenge we're trying to solve. Similarly, they're trying to enhance their agility, and they're always looking to improve their financial management and reduce their costs. What has changed is we're in a real fundamental shift in our industry right now. And all of those customer challenges are almost amplified when you look at some of the major shifts that are going on in the industry, right? In terms of mobile and how much data and content that's generating, in terms of social networking, in terms of big data and being able to manage all of that. And then finally, all the delivery mechanisms are changing from traditional IT models to these various cloud models. I mean, so, and we've had to respond to these changes every 10 years or so in this industry. And the latest one is this entire mobile, social, big data, and cloud. And you look at some of these, some of them are pretty comical. In the 1 minute I've been standing up here, right? There's been 208,000 minutes of Angry Bird that's been played, right? That's 5 months of Angry Bird being played while I've been standing up here. And so an incredible, right? It's incredible. Just an incredible amount of content that's being generated. And the key to this is consumers are expecting a different way of how they consume technology, right? They want the ability to have those applications anywhere, and they want to be able to request those applications in a new way as well. That has a major shift to IT. And to the IT companies and organizations that we talk to, they have to respond to these consumer pressures and all of this major industry shifts. What they're seeing is they have they have to be able to provide those infrastructure anywhere, the application anywhere, and all of the information that's generated from those infrastructure and applications. They have to be able to manage that data anywhere. And so we have this concept called services anywhere, right? That we're driving our entire strategy and point of view around. The ability for IT to deliver across multiple cloud delivery mechanisms or traditional delivery mechanisms, but give that consumer this infrastructure anywhere, applications anywhere, and information anywhere. Okay? So just as that's a bit of a background, what that is doing is changing the entire delivery model for IT as well. And again, I'll back up and say what I'm showing here in the first 5 or so slides is a point of view and a vision and a journey that we're going down, that we see our customers in the middle of today. And then I'll go through where we actually see the customers kind of stuck today and how we're helping them along that journey. So all those industry shifts, what they've done is they've changed how IT has had to reinvent themselves. Right? Traditional IT was along the far left side of that graph. Was traditional IT, they were the sole provider typically of a service or an application or an infrastructure within an enterprise. And what they've had to do now, because the business partners that they're working with, as an example, are going, in order to increase my agility, reduce my costs, and I'm going to go outside to a third-party outsourced development group, like or public service cloud, like an Amazon EC2, and that's caused a lot of pressure and a big nightmare for the IT organization, right? And so the IT organization has now had to become, instead of just being the sole supplier of infrastructure and service, they've now had to rethink themselves to be almost this broker. They've had to go look at all these third-party outsourced services and go, how do I still bring them and provide them to my end users, to my business partners? How do I still provide them and select them and be this almost this broker of those services? So they're still building these on-premise services, but they've had to go manage off-premise services as well. Okay, so that's the step we're in right now. We've moved from a traditional to where some companies are now starting to expand into public-private cloud models, and the IT organization is going, I've got to go manage and secure this entire environment. That's the issue we're facing. The problem with that, so we were in this kind of left-hand side maybe 4 or 5 years ago. Today we're in this kind of middle state. The problem with that state is when you move from one service and try to move it across these delivery models, you don't have very much portability, right? All of those stacks that you see in the middle have different architectures. For example, on Amazon EC2 is different set of hardware, different set of monitoring, different set of management metrics that you get from that service as an enterprise, and it's different from what you have in your own internal cloud. And so there's disparate architectures, a different management model, a different security model, inconsistent development environments. And so you have this problem where companies are now, some companies that made this first step into the cloud and maybe outsourced and went to a public cloud for some of their development environments, they're now stuck, right? They can't, in a quick and easy fashion, bring back that application internally, if that's something they want to do, right? Without a lot of reconfiguration of the actual application. And so this middle model that we're in is great from a flexibility and choice perspective, or from a choice perspective, but it's inflexible from an application portability perspective. And you see all the kind of challenges that they have in terms of different management stacks and things like that. So what we announced on earlier this week was this vision where on the right side of the slide, and we provide all of these today. We've been helping IT companies with their traditional service delivery model for years. We have a public cloud that's in beta right now, and we also have the private cloud. And so what we're doing is developing a common architecture across each of those delivery models, delivering a software stack that goes from a monitoring and automation standpoint that goes across each of those models, and that's a consistent stack, basing it on open standards so that the customer and the application and the service that you deploy can be deployed regardless of the delivery model. Okay, does that make sense? See some nods? Hopefully this example will show you what we mean by that. So we're calling this new point of view the HP Converged Cloud. And if you look at this example, think about a company who is developing some kind of mobile sales application, right? It's like a Salesforce kind of application that lets them access their sales data while they're on the road through some kind of mobile application. So, let's say a couple of years ago they decided to go build that application, test it in a public cloud model. They went to our HP public cloud model to develop that application. Now they want to roll that product into production, but because the application has feeds into the internal company database, they want to move that production in-house. So that moving from that step from 1 to 2 is really hard today. An application that you've developed in the public cloud is really hard to move back and bring into production internally in your network in a private cloud environment. what we're doing is going through a lot of work to define what we call a service model, and have a service model that's defined, that is defined independent of the delivery mechanism. And so we're putting a lot of work and content into, regardless of what application that they decide to develop, the actual infrastructure that supports that application, or the delivery model that it supports that application, it can be made portable across as you move back across. So, let's say they bring that application back into production, they have it running for a year or so, and they decide that it's working well, but every quarter they need additional workload. They want to burst that workload and they need additional performance, and so they can move that application back to some kind of public environment every quarter, or whenever they have some kind of bursty requirements. And so what we're doing is defining a service model that you can define the application, and the actual infrastructure elements are defined when you've provisioned and when you've decided what the deployment vehicle is, or the delivery model is. All right, so that's again, this is a vision and a roadmap. This is where we see a lot of customers today who've taken that first step in the cloud but are trying to make it portable, trying to make those applications that they've developed portable across multiple delivery vehicles. All right, so that's the HP Converged Cloud. Again, a roadmap, and we're delivering and breaking that roadmap up into multiple pieces. I'm going to share with you a technology we've got called HP Cloud Service Automation, which is one of the first steps of that. But what the Converged Cloud roadmap does is give you this concept of choice. It's open, heterogeneous, it's extensible. We're extending it to this adaptive and Moab partner ecosystem as an example. It has this concept of a management layer and security layer across all of those delivery components, and the same architecture and standards across each of those delivery components, which makes you able to manage and monitor that as you move it, as you move your application and port your application across those delivery mechanisms. And consistency, okay? So, as I said, one of the key applications in this is an application called Cloud Service Automation, which is available today and which is what we've integrated with Moab. What this lets you do is it is an automated application and infrastructure provisioning and monitoring engine. Okay, you define infrastructure and application templates, and I'll take you through a little process here. You define infrastructure and application templates, and you publish those templates to this catalog and portal, and your end users can go select those templates, and we have an automated engine that actually lets you provision that infrastructure. What we've done is that second bullet, we've augmented that architecture with workload management. So a lot of the key capabilities that Moab can bring to the table is this entire engine around policy-driven workload and the actual placement of where those workloads are going to, and the resources that are going to be provisioned for those workloads. Moab can help us intelligently determine where those workloads are placed based on their policy engine. So that's what we've augmented. So, real quick process, right? We have this, a service architect will go and define these infrastructure and application templates. They'll publish them to this portal. That end user will go and select that infrastructure template. The infrastructure will be provisioned through this CSA, and we're going to go through an actual example. It will be provisioned with the infrastructure, and the application will also be provisioned. And so, some of these service model concepts that I talked about of defining a service, defining an application, and the application being aware of the infrastructure that can support that application, we've included in this kind of product. So somebody asked a question this morning about, I think it was one of your healthcare customers about HIPAA, right? And or in the cloud session about HIPAA. And so a good example of this is, you can define your application to be an application that has a HIPAA requirement. And what we can do is we can look at the infrastructure and define a map between the application and infrastructure so that you're using an infrastructure and delivering an infrastructure that actually is already HIPAA compliant or based on HIPAA standards. And so that's the kind of content that we're developing and this mapping of application and infrastructure that we're developing in our delivery model. How we do that is, from an automation standpoint, we've been helping customers for years develop and automate their data center. And so we've had lots of practice in terms of the right applications and the right infrastructure to support those applications. And so we've developed about 100 plus predefined application deployment templates for a range of popular database, middleware, and application development platforms. And so we've got this history of best practices approach, and that kind of best practice knowledge we're putting into the product in terms of actual content. And so that's part of the value of this product and how we're furthering that service model approach. Whoa. Okay. I'm not going to spend too much time on this. It's a commercial of what we're going to talk about. What we're also doing is this area of workload management. When you're looking at placing those resources and provisioning those resources, you have to be able to intelligently place them. And so what Nathan's going to talk about now is the actual integration between Moab and adaptive computing, and then James will talk about the actual use cases. Okay? Thanks.
Thank you, Mac. Let me just say first that as an application developer, the vision that Mac just delivered aligns a lot with what I would expect from a cloud. It very clearly puts the ball in my court to define my application's needs because I'm the one that knows that best. So I'm really impressed with where they're going with this, and I'm really excited to see where it takes us in the future. I'm going to talk about the technical details of cloud service automation and how Moab integrates with it. So very simply put, leaving out a lot of the details, cloud service automation is an automation platform or an integration platform that you can use to bring together all the disparate parts of your application provisioning stack or IT infrastructure. The input to cloud services automation is end-user service requests. It has a RESTful API, which we all know that I really love. So I'm a fan of that. And the output is automated delivery and management of those services. So in order to do that, it requires a provisioning engine and a workflow engine, and obviously an end-user portal to submit those requests. There's optional components that do monitoring and standard configuration management use cases if you need those for your management use cases. So I'm going to go over the service lifecycle for CSA. Basically, it's broken up into 3 different parts: initialized, reserved, and deployed. And each transition is a series of configurable workflows. So I can put in workflows to do whatever I want during each stage of this process, which lets me integrate anything at any point in the process to make sure that the application is provisioned properly on the right resources. So during the initializing phase, we're making sure that all the components are on the same page as far as what the request needs. During the reserving phase, we're reserving resources, making sure that the resources are ready for use. And then deploying, we're actually going out and doing the provisioning steps, like creating virtual machines or setting up network shares, that sort of thing. So these 3 steps allow us to actually run through a request. And I've got this fancy animation to show how that's done. Basically, yeah, isn't that pretty? Yeah, I like it.
Spent days doing that?
Actually, only an hour.
Very good.
So the request comes in, it hits initialized. It keeps on going because there's nothing to do yet. In this particular workflow, we don't have any other components that are interested at the initialized stage. And then when it hits deploying, what it does is it basically creates a request. This workflow creates a request and sends it off to the provisioning engine to create a virtual machine. That goes and does its work, and then the application is essentially deployed. This is obviously with a lot of hand waving, right? I mean, we're not getting into the nitty-gritty about how all this works. I'm just trying to give you the concept. So now that I'm done with my VM, I want to decommission it, make sure that it's shelved off correctly. Again, as I undeploy it, a request is sent off to the provisioning engine to destroy the VM, along with archiving the storage for whatever purpose. And then we move back through the rest of the lifecycle phases, executing any flows during the unreserved or uninitialized phases, and or state transitions. And then the request goes away, essentially. What this allows us to do is it actually made it really pretty straightforward to know where to put Moab, because Moab is basically in control of all the resources and what they do, right? CSA is in charge of services and the delivery of those services, but Moab knows about resources. So what we did is we had this same request come down. What it did is it stopped at the initializing phase, and it sends a request off to Moab. Moab then converts that request into jobs in our terminology. So each VM is a job, each storage mount is a job consuming resources. We do this so that we can take advantage of all the existing very powerful policies that we've built into Moab. So we get that, and then the request moves on to initialized, and there it stops until Moab's ready for it to start. So it's sitting there at initialized. Moab eventually finds out, okay, I've got a resource that's great for you, a hypervisor picked just for you because I like you so much. So it sends this job start command to CSA and tells it to continue provisioning, keep on going. And from there on out, CSA is basically in control and continues on with the provisioning process to reserve the request inside of CSA, and then to continue the deploying with the provisioning engine, which happens about the same way, and then it's deployed. Now, while it's deployed, Moab will still continue to manage the jobs. So for VM migration purposes, Moab can take advantage of all the policies that we've built in and work with the environment to make sure that the service is being given the right amount of care and concern, making sure that it's running on the right resources all the time. And then eventually it comes time for this VM to go away. Again, we send off the destroy to the provisioning engine, and again, we move on back up to the initialize. So as we're uninitializing or destroying the service, a request is sent off to Moab, which then makes the jobs go away and the service goes away. So that's very high level what we do with this integration. And there's obviously some details, and I'd love to talk to you about that after in the Q&A session, or in the Q&A of this session. But now James is actually going to tell you about what we're doing, why customers really like this sort of architecture.
So thanks, Nathan. I guess I'm a solutions architect out of the pre-sales organization, so theory is nice, but what can we actually do with it? So it's got a couple of kind of entry use cases that I'm going to breeze through pretty quickly here. Again, the first one is really about where am I going to place my node or my service when it's being requested. And actually, the customer challenge here, or the importance of this, is that if you get this wrong, you can actually break stuff quite horribly. A lot of the hypervisors, for example, tend to give poor performance when they're heavily loaded. VMware, I guess, has an issue traditionally with a clock. If you're running something that's a heavy application like server automation, which also relies on certificates between the core and the agents, that can actually go very badly wrong if you start loading the VMware too much. So we need to kind of make decisions intelligently about what applications we're placing where. So just a little view as to kind of how we use Moab. We use Moab obviously as the intelligence engine, a decision maker, if you will, within our environment. We tell it what resource it has out there to provision, what is actually being reserved and in use right now, and what services are required and what those services actually need in terms of resource. So, they're going to need, do they need physical? Do they need virtual? How many CPUs? How much memory? What kind of performance characteristics can we go between? What's too low? What's too high? And so we can use Moab to intelligently decide, where we're going to place workload to give the optimum workload packaging or packing, so that we obviously have maximized utilization. But we can also use this same mechanism to actually make the world cheaper in some sense. So the traditional VMware model, I guess, has been that you've bought VMware licenses, and then you need to license everything that goes on there. So if you have 15 VMs, you have to put 15 licenses of Windows and your database or anything else that's on there. But we've seen in recent times, particularly Microsoft and Oracle have come forward with some very aggressive licensing plans for their hypervisor technologies, whereby you don't actually have to buy one license per VM that's going out there. So obviously it can be much cheaper to place Windows workload on a Windows Hyper-V instance, for example, rather than to use a different provisioning method. Second use case we're going to talk about here, time-based scheduling. Obviously, being able to reserve and then provision things inside in the future inside my environment. And again, the real kind of user example here is kind of development organization that has a release, a major release, which they know ahead of time when that's going to be released, and they know that they're going to have probably about 2 months worth of QA cycles in that time. And so that's obviously a very important utilization. We're going to need those resources. We want to be able to reserve that resource so that nobody else can take that from us. It's available to us when we need it. Similarly, I guess DreamWorks is an example of a company that's worked with HP on a lot of their rendering and interested in using cloud for that. So obviously again, before the release of their motion pictures, they need to go through a heavy rendering process for that, and again they're going to need resource and be able to reserve that along the way. So I guess this is a view of how that looks inside CSA and the service request catalog. I guess the important thing is that the integration with Moab has not required us to make any changes to the user experience. So this is the kind of standard dashboard that a non-technical end user would see. So they're seeing the service requests that they have out there, any actions they performed on those things, and can use this to browse a catalog and to select services that they're going to be putting out there. So in addition to the parameters that we can give now to an end user in provisioning this service, we've now added a kind of start time and optionally end time for the service itself, so that when they go ahead and submit this, it now goes, rather than going into a building state, we're going to hold that subscription at a pending state. And Moab's going to be watching that and using its own calendaring activity to decide when that service needs to be provisioned. So when my service time becomes available, Moab wakes up, just as Nathan pointed out, tells Cloud Service Automation to begin provisioning that system, and we have our service out in the environment to use. Just a vision of kind of how that looks in a timeline graph. Got my nodes up on the y-axis there, and time moving across the x-axis. So you can see now that I've put my, as a long-term owner on the top there, but I've put my reservation in underneath. You'll see some other people using this in blue. So as my reservation time comes up, CSA provisions my service. All the while, other people are also provisioning their own services, and so we see this system where Moab and CSA is leaving my reservation alone, so that I have my guaranteed SLA and my guaranteed periods there. You'll notice actually that we have directly after that a period of maintenance, so a maintenance reservation. As you might imagine, we actually have reservations or requests that are of different priority. Now, you might consider an emergency maintenance request to be a top priority system. So essentially, any time that something needs to go into maintenance, I've had an incident in my environment, I have to then use that as a top priority signal and react accordingly inside my environment. So here we've got this kind of use case here, which is, I guess, a sub-use case, which says, if I have a very high priority job, or I have a maintenance job, or I have an incident that requires me to move things around, I need to be able to handle that. And again, we go back to Moab, which understands the environment, understands what resources are available, what resources the service needs, in order to kind of make those decisions. So you'll see here another view of my world. My grey box is there, representing the environment, the resources that I have. The blue box is showing workload that's distributed on those. And I've got my own reservation there in the big green box. Now, if I see that I have an incident that comes in from a monitoring system, such as SiteScope was included by default out of the box inside CSA, you'll see now I have to take account and actually do something with the workload that's on those 4 machines. So again, we go back to Moab. Moab makes a decision about what resource is suitable, and we're able to move that workload across into free resource in order that I can now bring the problematic pieces under maintenance and work from there. The third use case we're going to talk about really kind of extends on from there, which says, this is dynamic workload management. So when I'm receiving signals in from my capacity management tools, from my incident management tools, all sorts of kind of monitoring that's going on there, how do I dynamically change my infrastructure to respond to what's going on in the environment? I'm going to go back to my diagram there. My grey box is representing the environment that I have. And you're seeing the different types of workload in the blue and black boxes there. And really you can see now that, after a while I've ended up with, a large number of hypervisors being used. But particularly in the lower left corner, a lot of those hypervisors are under pretty low utilization. So obviously that's a fairly poor use of my environment. So I can go again back to Moab to decide how I'm going to react to that environment, and actually to move some of those low workloads onto some of the machines that are already in use. So here now I'm going back and consolidating my workload onto much fewer systems. How big a problem is this? So in the HPC world, I think Rob Clyde said in his keynote speech that we're well used to kind of utilizations of 90%. In the enterprise, we're more used to somewhere between 15 and 20. So this is obviously causing us to require to buy more infrastructure, more hardware around this. If we can increase the utilization, as we've done in some of our customers, up to around that 80% mark, that gives us a really large bang for the buck there with something like this. So a couple of use cases, again, sub-use cases within that. The reason that we need to do this in an automated fashion is that if you're in an environment such as a medium-sized enterprise, there is so much change happening in this environment that simply the IT staff can't scale to support these processes manually, and essentially need to do this in an automated fashion to get this to work. Now, obviously, if you're doing this manually, lots of problems in terms of potential conflicts and mistakes. Again, automate the process to enforce those SLAs and make those resource decisions. Again, the reducing capital expense example that we kind of looked at briefly, again, consolidate the workloads that we have rather than running those on expensive systems or systems that are under low utilization. Let's move those into and consolidate that workload onto fewer pieces of hardware. Bringing that capacity up to 70-80%. And again, the kind of converse of that is we need to be aware that these application services need to run under a specific service level agreements, and that means when I see my capacity management, my monitoring coming out and saying there's an issue with application, I can actually decide then how to scale that out and then to give additional resource accordingly. So just a kind of diagram of that, as we see, these blue things moving around, workload consolidating onto various machines, and then my green workload, which says, you know what, this is actually growing. I need to move this onto something that has more capacity inside the environment. And then conversely, or at least additionally, while that's going on, we may actually have a failure that goes on in the environment. So I have to do the same thing, but also move the existing workload out into free resource. So again, you don't want to do this manually. You have to get an automation piece to make the decisions as to what's going to go, coordinate all those decisions, understand what is available, what's in use, what's being reserved. And we use Moab in coordination with CSA to do that. Lastly, on the use case, Showback and Chargeback, which I think is one of the real hotspots of cloud computing right now. One of the reasons why it's really important is because to discourage the VM sprawl that we see with standard virtualized environments. So essentially, there are two reasons why cloud is good to reduce VM sprawl. One of which is people believe that they can get their services back, so they're more willing to give things back. But also, if you encourage them by either showing how much they're costing the business, or better still, charging them somewhat for doing that, they're more likely to give back resources that they don't need, and then just call them back when they need to. So again, business teams, users don't really understand what the cost of services are until they move into a cloud environment like this. So we need to be able to kind of capture costs, obviously show what kind of costs are involved when we're looking at a service catalog in terms of provisioning and ongoing cost, but also to then kind of give a monthly bill as to what's going on. Make sure that organizations understand what they're using inside their environments. That also allows us to kind of plan for future capacity needs and help us to move forward with ongoing service usage. The kind of things that we measure there, obviously we're going to calculate an overall service cost for approval. Essentially, the normal way to do that is to say there's a service setup cost plus an amount of time per service. Need to be able to kind of cope with flexible charge rates and models. So we talked earlier about how I might use different hypervisors to make my service cheaper. Some organizations may wish to actually reflect that back to the end users of their service limits to encourage particular behavior from end users. And then we need to obviously track the kind of chargeable resource units. So to encourage people to not just buy the biggest one available, charge by memory, charge by CPU, the time used, what the service is, what the applications are running, and obviously integrate with existing accounting systems for chargeback there. So we use a component of Moab called the Advanced Billing Manager, I believe, Nathan?
Accounting.
Moab Accounting Manager. Yeah.
Thank you very much. To do this, again, out of the box provides us with all of the resource usage. So who's used what, who's put what out there in terms of services, and gives us the ability to provide both a consolidated report back to management and the individual billing reports back to the end users themselves. We have some additional capabilities that we can add with professional services, again, to reflect kind of flexible charge rates according to some of the parameters like the actual cost of various infrastructure that it's gone on, and again, the ability to kind of calculate for pre-approval as well. This is a couple of views of actually what this looks like in terms inside the accounting manager. So again, this is a consolidated list of the transactions that are out there, including the users, what's been out there, how long they've been using it for, a view of the charge rates themselves, and then finally the kind of bill that you might send to an end user, saying what they've used, when they used it, very much like a kind of standard phone bill that you might get from your cell phone or even the old style provider. So at that point, that's kind of put forward the 4 initial use cases that that we see most of out there. I guess this is 4 of I think we're up to about 27 now that we think we can integrate Moab and CSA to provide real value to end users. So at that point, I'll stop and ask my 2 colleagues to join me up here and take any questions you have.